Okay, so let's talk about section 2.3. Section 2.3 is all about analyzing those graphs. And what we're going to learn as we analyze these graphs is we're going to look for misleading characteristics of a graph and kind of things that you want to pay attention to. So the first thing is how to properly label a graph. There should always be a title. No matter what type of graph or visual data you have, it should always be labeled with some type of title. If you are using data that's not your own personal data, say you pulled it from somewhere, you should probably include that source if you've pulled it from somewhere in particular. And then also, however you're labeling it, make sure that that horizontal and vertical axis are labeled. In our case here, we're looking at a bar graph that has been tilted on the side. So normally we like the bars to go vertical, but this one's going horizontally. They have labeled what each bar actually represents, and they all start at one part. And then from there, they kind of come off the bars. From that vertical axis, they kind of come out. And we do see that millennials have a smaller bar, whereas Gen X and boomers have a slightly longer bar. And it makes sense because the number is slightly larger. And then the silent generation, they have that in really large number. Again, noticing, and this is something that if you did not recall from the last video, I mentioned that if you're going to use numbers, so in these numbers here, somewhere it also talks about kind of like what those numbers actually represented, and all of these are a percentage, so they're referring back to a percentage. Okay, appropriateness of the graph. Make sure that the graphs are actually showing what they need to show. If it's a time series graph, it's very, very positive that it should show the displaying variable that changes over time. And again, anytime that we have a time series graph, normally the horizontal axis, this is the time, okay? The variable is normally on the vertical side of it. A cross-section graph, and we didn't talk about this one too much in the previous section. It just basically displays data collected at only one point in time. So basically you're taking a graph and you're taking just a small part of it. A pictograph is basically a bar graph, but instead of using bars, it uses objects. These be very leery of because they can be very deceiving. So here's a nice pretty picture of a pictograph, and it is actually quite deceiving. If you look at it on this left-hand side versus the right-hand side, what is wrong between the two? So this one is the correct way and this one's the incorrect way. And the reason why I say this one's the incorrect way is it kind of makes that 2010 look way bigger than it actually is. This picture is a lot wider than this picture here. And in order for a pictograph to be correct, all of those widths need to be the same width. And so the picture should look distorted. If the picture doesn't look distorted, then your pictograph is probably a little deceiving and not correct. Okay. Another important feature to look out for is that the scale is on a graph, it's actually correct. If there's any stretching or shrinking on the y-axis, the shape of the graph, it may change dramatically. That's normally a good indicator that something's wrong. If a line that rises gently on one scale might look a little steep on a different scale, these things are kind of confusing. A lot of times if people like shift where the scale starts versus originally where it actually starts, can kind of change a perspective of how a graph actually looks. So when analyzing a graph, just make sure to check that the scale represents the data really well. I know in some previous elections, people were sharing data of graphs and they were like, oh, hey, take a look at this. And this looks so good. And I'm so much further ahead over this person than the other. And it wasn't actually a huge amount of difference between these two candidates. It was actually just that the difference was really small, but when they changed the scale and stretched it, it made it look like it was a bigger difference than it actually was. And that's kind of deceiving. Okay. Here, if you look at this graph, again, the scaling, really definitely something that you want to kind of play with. Consider this graph. How would you go about fixing it? It's meant to be talking about federal minimum hourly wages unadjusted for inflation. What can we see that we might want to fix about this graph? Well, the first thing I want to see about fixing about this graph is I'm noticing down here on the dates, they're not consistent whatsoever. Okay. You'll notice here we go from 38, 39, 45, 50, 56, 61, but these are all evenly spaced, but these are not all the same distance apart. And that's just kind of one of the few things, just looking at the years. I also noticed that all the data is not taken in the same month. So here I've got March, here I got September, here I've got May, I've got January. So that constant change that you see there is quite deceiving of actually how it might actually look for those hourly wages. Okay, so that would definitely be something that I would want to maybe change. Okay, I do suggest that if you will take a look in exercise 10 in chapter 2, you can kind of see what the actual correct graph should look like. Okay, shapes of graph. These are things that we look for. Is the graph uniform? Is it symmetric? Is it skewed to the left? Or is it skewed to the right? The reason why we look at these shapes is they're a real good way of determining if something is possibly an outlier. An outlier is a data value that falls outside the normal shape of the graph. And we have 4 basic shapes that we're looking at. Our first one is uniform. And with a uniform, it's really nice. Think about it. Uniforms are pretty straight and rigid. So it should be kind of very similar across the item. A uniform frequency, just basically they're somewhat the same. There might be a little bit discrepancy, but majority of the time it's pretty much the same. For something that's symmetric, it's going to look again like it's kind of evenly on both sides. It should look symmetric about something. If it is skewed, we'll start with skewing to the right first. So skewing to the right means basically, if you'll notice, the data here kind of looks like it's a little bit longer on this side. So it looks like I've kind of just pulled the data to stretch it out on this side. And again, I'm pulling. And which way am I pulling? I'm pulling to that right-hand side. And so that's why we'd say it's skewed to the right. If I look at skewing to the left, it again should look like I've kind of dragged the data in a certain direction. And in this case, it looks like it's been kind of dragged to the left a little bit further. So I would say skew to the left. And these are normally good indicators of something that's probably going to be an outlier if you have something that is skewed. So in this case here, I'd probably say these items here for these minutes may be possible outliers. I'm not 100% sure if they're an outlier, because I'm going to have to run a couple of tests to do that. But again, it's kind of that idea of the direction that they're being pulled. Okay, so let's look at this beautiful graph and let's talk about the overall shape. Let's kind of describe it. So the first thing I notice is it's not perfectly straight across the top, right? So we can rule out it being uniform. But I do kind of notice that it's kind of like even on both sides. It's not perfectly even, but it's pretty close, it looks like. So because of that, they almost look like mirror images of each other. This would be where I would say this is our nice, lovely symmetric.